Hey guys, this is Ron. So we've covered logical operators, we've covered strings, we've covered lists. I'd like to take the opportunity now to talk about loops. So in your program, you might find that you have an object like a list, and that list contains, a bunch of numbers or something that you want to, work with multiple times, or maybe there's some type of function you want to perform and you want to perform it across every one of the values within that list. So if I, let's say, built a list here, we'll call the list just test. And this list is just going to contain a bunch of, let's say, numbers. So I'll take 15, I'll take 14, I'll take 85, 95, 12. Really doesn't matter here. Just needed some numbers to work with, right? So let's say we want to find out of all the numbers that have been entered into this list. I want to find out which ones are even and which ones are odd. So rather than do them one by one, so I could do test 0, and 0 is this first value here, right? So I want to find out, is it even or odd? So how do we test that? Well, we can do our modulus 2 again. And if I get a 1 back, I know that the number is odd. If I get a 0 back, the number is even. So in this case, 15 is in fact an odd number. But rather than do them one by one like this, I'd rather build something that would iterate over the entire list for me. And so now I only have to write that test one time. So what I can do is I can build a for loop. So for, and here I'm going to specify some type of variable name. And it's pretty common to see some programmers get lazy, like myself. So we'll do for x in test. So what this is going to do is for each value that's inside of test, so 15, 14, 85, so on and so forth, one by one, those are going to get moved into x. And then from here, we're going to perform something based on x, right? So if I hit enter here, I'll tab over and I'll do something like this. If x percent 2. So what this is going to do, again, is perform this function. And so what we should expect to see is we're either going to get a 1 back, or we're going to get a 0 back. So the if statement, if it sees if 1, it interprets that as true. If it sees if 0, it interprets that as false. So basically, anytime it sees 0, it's going to be false. Anytime it sees something other than 0, is pretty much going to be true, right? So here we'll tab over again. So print, we'll do our formatting here. So blank is, and let's see, so if it hits this line, that means it was a 1, which means this is an odd value, right? So dot format, and we'll put x in here, right? Else print is even. Okay, so what we ended up with, again, test refers to this list. Lists are can be iterated over. So each of these items within test will end up in x, and then we'll perform this for every one of these. So the first time through, 15% 2 gave you a 1, which means it printed it's odd. The next time through, this time it's 14, so 14 gets moved into x. 14% 2 comes out as 0, which evaluates as false, so it comes down here and prints is even. All right, and so it really wouldn't matter how long this list is. It's just going to continue running through it till it gets all the way through the list and stops. All right, so that's your basic for loop that allowed us in this case to test a list and find out if the elements within that list are even or odd. Now what if you wanted to build a for loop but you wanted to auto generate some of the numbers? You don't necessarily have a list that you're working on, you just want to do something with a range of numbers. So there are two things that we can do here. We can do for x in range, and then we specify an integer value here. So let's say we specify 20. We'll do this. We'll do a print x. So we're just going to keep it simple here. And so what we see is the range command generates numbers for us. And generate might not be the right terminology here, because we will definitely talk about the difference between iterators and generators later on in the tutorial. But suffice to say, this range command output everything from 0 up to right before it got to 20. So there are 20 different values here, but because again it starts at 0, we never see 20, right? Well, if we did a very large number here, what we would find is, at least in the Python 2.7 world, this adds some inefficiencies into our program, because the range command itself actually builds a list containing every one of those elements. So if this was a number obviously a lot higher than 20, let's say it was 20 million or something like that, well, that's a very, very large list. And so we might run into memory errors. We might run into just the fact that our program slows down when it gets here, because again it has to build that humongous list and then use that list one element at a time, right? Well, there's another command called xrange. And so xrange, instead of returning a list, it returns an object that generates the numbers in the range on demand. So if I had 20 million items that I wanted to iterate over, instead of like list where it would generate a or unlike range where it would generate a list containing 20,000 or 20 million different entries, instead I'm going to build this list on the fly. And so I never have to fully build 20 million values. Instead, as needed, it generates that number for you. And so it's much more efficient to use xrange in 2.7. Now with 3.5, they basically got rid of range. Well, they didn't get rid of range. They just made range equal to xrange, right? So instead of having to build this list out first, you can just run range and you're basically running xrange. So they took the efficiencies and they made it the default rather than having a separate function that's more efficient than, say range. So they know, people are just going to use what they know, and maybe what they know is range, and so they are constantly building inefficiencies into their system. So to negate that, they just made xrange the efficient version, right? So in our case, we could go back up here, but instead of using range, we can use xrange and then print x. All right, so it looks the same to us, but to Python in the background, it's much more efficient to run xrange. And so my advice to you is to always use xrange instead of range. So we've covered putting a list there. We've covered having our numbers auto-generated for us using the xrange command. Well, there's another command called enumerate, and this command will become more valuable when we see objects like dictionaries, much more friendly, in that respect. But you can also use it for a list. So we had our test list, and maybe I'm not only concerned with the value that's in each one of these, but I'm also concerned about the position that they're also in. So not only do I need to worry about 15, I need to know that 15 is in the 0 position. 14 is in the 1 position. So I'm worried about these index values as well as the value themselves. So what I can do is I can do a for, and what you'll see here is kind of shorthand. We haven't covered tuples yet, but you'll see this kind of look like a tuple, because in essence it is. So I'll have shorthand I will represent my index, and then I'll have my actual value. So we'll see I comma v in enumerate, if I could spell, enumerate test. So what's going to happen, and we'll just print them out. So we'll do a print I comma v. And so what we end up with is v ends up with the value that's in here, and I ends up with the index that value sits at. So when I print that out, what I end up with again is a tuple here, which again we haven't covered. We'll talk about it a little bit later, but I end up with index position, value, index position, value. And so this enables me to keep track of where I am in the list. So again, as I work through this, it may allow me to refer back to a previous item, because again, I know the index value that I'm currently sitting at. So I know if I'm at 3, well then I should have already gone through 2, 1, and 0. So I mean, again, depending upon the type of function that you're performing, what you're trying to do, it might be valuable again to know where you are in the list. So as we get to dictionaries, it'll be even more important that we understand where we're pulling some of these values from. And so the enumerate function or method is quite valuable, especially in consideration when we use it inside of our loops here. Okay, because again, it keeps track of not only the value that we're currently working on, but at what position we're in from the list. Okay. Now there's 2 other commands that I want to cover, and one is called the break command. So let's say I have a list that I'm working through, and maybe I'm testing something out. And so in our case, we have this test list. Let's modify our test. Again, this isn't going to make a ton of sense based on the numbers because these are really simplistic, but we'll do something like this: 11, 13, 15, 18, 25. All right, so we're going to go back to testing for even and odd numbers, right? But instead of just printing them out, I want to stop iterating over the list as soon as I hit an odd number. So we'll do a for x in test if we'll do x percent 2 equals 0. And And we could have done an if not x%2 again, which would have been, you know, we did x%2 before. That always came out to a 1 or a 0. If it was a 0, that evaluated as false, which dropped us into the else statement. So I could have done an if not x%2. And so that would have basically flipped that false, made it a true, and so we would have been in the top half. But either way, we'll do if it equals 0. So this tells me that we've hit an even number. We'll print is even. Alright, so dot format, just like we did before. We'll do x, and oops, I missed putting that second bracket on there, so we'll go back. So for x in test, if statement, our print statement. Let's make sure I've got enough brackets. It should be 2 brackets, right? No, it was, what am I doing wrong? Oh, I forgot the quote. Lordy, Lord. And then we'll break. And then we'll put an else here. Print. We'll just put odd, because I've made enough typos in this one. So the first 3 numbers were odd, boom, 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 and then we finally hit an even number, and guess what? We quit. We had 25 still to do, but we didn't even get there because, again, I told it to break. And what break does is it kicks you out of the loop that you're in. So it broke us out of this for loop. So we found the condition that we wanted, and we broke. All right. And so you might find that, again, you're looking for something particular within a list or within whatever you're iterating over. And as soon as that becomes true, as soon as you find what you wanted, you break out of the list, because there's maybe you're trying to gain some efficiencies. I've had some programs where, again, I was testing, you know, some type of condition over and over and over again, and so maybe the data set that I was working with was quite large, and so I don't necessarily want to have to iterate over the entire list. I just want it to go until a certain condition is met, and then kick me out of the loop so that I can move on with the rest of my program. And so I gained some efficiencies by not processing the rest of the list. That doesn't matter. I've already found the condition that I was looking for, so there's no sense in continuing to iterate over the list. And so again, this might be a design decision that you make, is, hey, as soon as this condition is met, break me out so that I can continue on with the rest of the program. All right. There is another command called continue. Right? So in continue, instead of breaking us out of the loop altogether, instead what it'll do is bring us back up to the top. And so there might be a reason that you want to do that, in that, okay, so in this case we tested to see if a certain condition was met. Well, there might be a reason for you to test towards the beginning, and instead of let's say my for loop is long, there's a lot of code in here, so if I already know at the beginning that this piece of data doesn't apply to what I'm trying to do, instead of continuing on and processing it, I'll run the continue command. So in our case, this doesn't make a whole lot of sense. Let's say we'll do a if it equals 1. So kind of the opposite of what we were trying to do before. I'll just put a continue. else print, let's put my quotes in this time, is even. So here I only got back even. So I processed the entire list. I went through every portion that was in test one by one, okay? But what this said here is if I get x% 2 equals 1, which means I've hit an odd number, I just want you to continue. So what this does is it goes back up here and starts with the next value. So I've basically bypassed everything that exists underneath of this continue, everything that follows this continue. And so I don't even process. And again, this for loop might again be very, very long, very complex. And if I test right off the bat to see if a certain condition is met, and it is or it isn't, I can force it to start back with the next value because maybe the value that I'm currently looking at doesn't apply to what I'm trying to do. So go ahead and continue, start with the next value, and then try again. So in my case, for every odd number, it did that. It jumped back up, started with the next number, tested it. Is this even or odd? Oh, it's odd. Well, then I don't care. So come back up here. So the only time it came down here was if it found an even number. And so if my list, let's say test, if my list was, you know, a little bit more, let's see, I had a couple more even numbers. Oops. So now when I go back to my list, so I'll do an if, continue, else, and my print. So again, it only keys on the even ones, right? Everything else just gets kicked back out up to the top and starts with the next number. And again, for this scenario, it doesn't make a whole lot of sense because there's really no extra code down here that would have gotten executed. But in the case that again, your for loop is, you know, quite full, you may want to gain some efficiencies by, again, if what you're trying to do doesn't apply to the current data set that you pulled out, then just continue, move to the next data set, and then try again. All right, so break forced us out of the loop, continue forced us to go back to the top of the loop and start with the next value. Now there is another loop out there. There is the while loop. So whereas the for loop always kind of executes given you know, some type of iterable that you're going to iterate over, the while loop is a little different. So you would do something like while, and you're going to have some type of test condition in here. So let's say while, well, let's do this real quick. We'll create a variable called x, and we'll give it the value 1. So while x is less than, let's say, 10, we're going to print x, and then we're going to add 1 to x through each iteration. And so what we get is it's going to test this first. Does x currently, is x currently less than 10? Well, the current value is 1, so yes, this evaluates as true, which means we're going to run what's inside the while loop. We're going to print it, and then we're going to add 1 to it. So now this time around, x is 2. Is 2 less than 10? Yes. And so it goes through until it gets to the point where this no longer evaluates as false, and then it it stops going through the loop and moves on with the rest of your code. So you have to be very careful with while loops. Let's say I forgot to add this statement in. If I didn't add this statement in, x will always be equal to 1, which means this will always evaluate as true. So this becomes an infinite loop, and I would begin printing x, a bunch of ones forever, right? It would never stop until I killed my program, right? So you have to be very careful with while loops to ensure that you don't create infinite loops, right? So you can, the one cool thing about a while loop is, again, it's only going to go through this loop if this evaluates as true. So there might be a case where depending upon your values and whatever, you're going to come to this while loop. This automatically is already false because of whatever your values are at the current time. And so your while loop never gets executed. But what you can do, let's say I made x equal to 11, right? So obviously this while loop should not execute. So it doesn't really matter what I put in here because I already know that it's not going to execute. Well, I can put an else statement here at the bottom of my while loop, and I could say print while loop is done. And so what I get is while loop is done, right? So this evaluated as false. It never made it into this portion of the loop. Instead, it chose the else path and executed this. So now if I go back and I'll put x equals 1, what I'll find is that I can do while x is less than 10. I've got my print x. I have to add to 1. So before we did x equals x plus 1, there's a shorthand version of this that is plus equals 1. It's the same. It just takes x and assigns it the value of x plus 1, right? So this is just the shorthand version that you'll see. Now we can do our else statement, print while loop is done. And so what I get is what I had before, where I added 1 each time, so it went all the way up to the time that now this is equal to 10. Is 10 less than 10? No, 10 is equal to 10, right? So this evaluates as false. It kicks down here, does the else statement, and lets us know that we're done. So there might be some type of, I don't know, cleanup that you want to do where you had done some type of operation, and then once this is no longer true, you do some type of cleanup here to, I don't know, some kind of final portion of your program. All right, so that's pretty much it. I know I went a little bit long with for loops, but you'll see them over and over within people's code, and again, you're going to want to use them depending upon the types of functions that you're going to do. But it definitely saves you code because, well, you only have to write it one time instead of writing it over and over again for every element within, let's say, a list. So thank you for watching. Hope you got something out of it.